Alright, this section's over solving linear equations, topic you did in Algebra 1, so it should be mostly review. Start out with some vocab here. So we have the word equation. This is a mathematical statement that two expressions are equivalent. We get in the habit of using this word for just anything. Anything that's written down that looks math, we say that's an equation. Okay, that's not exactly true. Equations have to have an equal sign. They have to be equivalent. If there's no equal sign, then they are just simply an expression. You'll see that word used right here. Alright, the solution set of an equation. We talked about what just a regular set was. So a solution set is the value or values of the variable that make the equation true. Okay, so anything that solves the equation is part of the solution set. Linear equations only have one. Quadratic equations have two. Inequalities have a range of solutions, so there's a lot of different ways you can see a solution set. Linear equation in one variable can be written in the form ax equals b, where a and b are constants and a cannot equal 0. Okay, so that seems like kind of a mouthful there for just something simple as this, but a cannot equal 0 because this would be 0 times x. There would be no x in that case, and you can't have an equation without a variable x. Okay, and then a and b are constants. Okay, hopefully you're familiar with that word already, but if not, that just means that they are actually going to be numbers. So something like 2x equals 4 would be an example of what an actual linear equation would look like, with a and b filled in with constant values, with numbers. Alright, so down here we just have some examples, so definitely want to write this table down as we go through it. So these are examples of what linear equations may look like. So 4x equals 8. Okay, that's kind of like what we just wrote down up there. 3x minus 2/3 x equals 9, negative 9. And 2x minus 5 equals 0.1x plus 2. Okay, all of these have just a single variable x, and then they are being multiplied by something and then possibly added with another constant or set equal to another constant. So here are some nonlinear equations. You've got 3 square root of x equal plus 1 equals 32. 2 over x squared plus 1 equals 41. And 3 minus 2 to the x equals negative 5. Okay, I have a little question over here for you to answer. So you can pause the video and just answer these. I'll ask you about these tomorrow when I see you all in class. So where is the variable in the nonlinear equation? So where is the x located? And then write down how is that different from where the x is located in these over here. Alright, we'll discuss that in class. Alright, so the first thing we're going to do here is do an application problem for linear equations. Again, something you should be familiar with from Algebra 1. So just some quick review. So this local phone company charges $12.95 a month for the first 200 minutes of airtime, and then they add plus 7 cents for each additional minute. If Nina's bill was $14.56, how many additional minutes did she use? So we want to write out an equation. First thing you need to do is define your variable. Alright, and in this one, you'll usually see it after the word like for each or per, P-E-R. Okay, so minute. Okay, this one's a little bit trickier though because they have this thing where they charge $12.95 for the first 200 minutes. So we're going to use an M for minutes, but instead of it just equaling minutes straight out, it's going to equal minutes above 200. Alright, because you see right here it says for each additional minute. So each one that you go over your 200, you're charged an extra 7 cents. Alright, so let's write out an equation that uses this. So anytime you see for each, the number in front of that is going to be multiplied by your variable. So we're going to say 0.07 times m. You can just write it next to it. That's understood to be multiplication. Okay, plus the $12.95 flat rate she has to pay, equals her total bill, $14.56. Alright, and we can solve this. Okay, and I always have So especially at the beginning of the year, draw a line down your equal sign. This will help you keep each side straight, okay, and keeps your work organized. You want to work straight down. Don't start working across or randomly all over the page. You want to stay organized. Okay, so the first thing we want to do here is subtract 1295 from both sides. Alright, that cancels it out over here on the left side and leaves us with 0.07m equals. And then we subtract this over here, so that's a 1. 15 minus 9, that's a 6. 3 minus 2 is a 1. 161. Okay, and then we're going to divide this by 0.07 divided by 0.07. Okay, when you divide, that cancels out multiplication, which is what was happening here. So 0.07 cancels, that leaves us with m equals. Okay, and then this one, when we have these weird decimals, we're just going to use our calculator. Okay, so you can plug that in on your own calculator. I'll do that as well, divided by 0.07, and hopefully you came up with what I got, 23 additional minutes. With word problems, you always want to clarify what you were solving for. Okay, and then especially you want to go back and make sure, does that make sense? Okay, so her bill was $14.56. That is more than the flat rate $12.95. So that means she had to have gone over a little bit. Okay, but not a whole lot. Okay, it's only $2 more, not even $2 more, $1.61 more. So 23 minutes seems like it's about right for where we are. Okay, if you get like 2,700 additional minutes, then you want to go back and check your work, make sure you didn't multiply where you should have divided, or added where you should have subtracted, something like that. Alright, moving on. Example 2, solving equations, and I put in parentheses here with distribution. Okay, we learned about the distributive property. We've already kind of used it this year, so this should be already familiar. Number outside the parentheses, and there's more than one term. So this one has 2 terms. Remember terms. So we distribute, and it's going to multiply by both. 4 times m, that's 4m. 4 times 12, that's 48. Equals negative 36. Now it looks pretty much like our last problem, just we don't have decimals in there, so we're just going to subtract 48. Cancels that here, leaves us with 4m equals. Alright, now we're doing a negative minus a number, or a negative plus a negative. So we're just really adding these together, and they're just going to be a negative number. Alright, so that's going to be, looks like 84. Negative 84. Okay, then we have a number multiplied by our variable, so we divide to get rid of it. Divide by 4. And those cancel out, leaving us with m equals 84 divided by 4 is negative 21. Alright, and our last problem over here. And you'll notice that this one says variables on both sides in parentheses. So you'll see that when we draw our line down our equal sign here, we have a k on the right side and a k, multiple k's on the left side. Okay, over here we only had an m on the single side. So this is just going to add an extra step. Okay, again, not anything you're unfamiliar with. Before you want to try to get those on the same side, you want to first simplify both sides as much as possible. So the left side, for instance, I notice I have like terms. I have a 3k and I have a negative 14k. So I can combine those together, add the coefficients. 3 minus 14 is negative 11k. Nothing to do with this 25, so we'll just bring that down. And then over on the right side, I notice I have 2 constant values that are like terms that I can add together. So I'm going to write my k first, negative 6k, and then 2 minus 12 is negative 10. Now, it really doesn't matter where you go from here. There's going to be a lot of times there's many different ways to do it. I have the way I like to do it that I think is the most efficient way, quickest way possible. But if you like to do it a different way, you feel free. Okay, so I like to move the most negative value over to the other side. So 11 is further to the left on the number line than negative 6. So I'm going to add 11k over here. Okay, so that's going to cancel that out. It's going to give me 25. And notice how I wrote it under the k on this side. Okay, because those are like terms, I'm going to be able to add them together. Negative 6 plus 11 is 5k. Then I just bring down my negative 10. Okay, next I need to move my constant values, the ones that don't have a k attached, over to the other side. So I'm going to add this so it'll go away from the k. It's going to move over to the left over here. That'll cancel out there. It leaves me with 5k equals 25 plus 10. That's 35. Alright, then we're down to our last step. We have something multiplied by our k, so we're going to divide by that value, divide by 5, divide by 5. 35 over 5 is 7. The 5's cancel here. 7 equals k. Alright, and that's pretty much all we're going to be working on in this section.